I think we should start now. So I will start with already we have one lecture from sir. So I will give quickly a brief introduction for sir. So sir is an associate professor in Department of CS at NIT Delhi, India. He has previously researched as a Dean of Research and Consultancy as HOD at NIT Delhi. Sir earned his PhD from IIT Kanpur, further solidifying his expertise and commitment to academic excellence. Sir primary research interests span a diverse range of areas, including network theory, dynamics on and off networks, epidemic modeling, synchronization, AI and ML, quantum networks, video caching, and time varying networks. So over to you, sir, for further proceedings.
Okay, thanks for the introduction. So just wait, I'm joining now. So just wait. बंद कर देना बंद। Share, just wait, I'm sharing the screen, share the window. So can you see the PPT now?
No, sir, we are seeing the WebEx portal.
Oh my God. Share the complete screen. Stop sharing. Share, continue. I think I have to share complete. So can you see now?
Yes, sir, we are seeing WebEx portal.
Okay.
Complete
Is
window.
it is moving? Just check moving. No?
Yes, sir, it is moving. Yes, yes. We can see the slide now.
Uh, just wait. I think there is some share the wrong one. Just give me 2 minutes time.
Okay, sir.
This is one. I think this is second. This is sixth, fifth. There is fifth. Fifth is this. Okay, fine. Sixth is this. Contribute. Uh, just wait. Where is fourth? Fifth. Relative quota. System. This is fine. 4 is fine. 2 is fine. Good. I think we should start now with this. Okay, I think this is correct. And now we can start. Actually, what happened, I have changed the PC, so it is appearing in different way.
Okay, sir.
Okay. So now we can start our topic. First of all, thanks for introduction and invite and give me the chance for the second lecture also. So if you remember in first lecture we talked about some introduction about the parallel computing. Sorry, this cloud computing and about its security also. So now, actually, once we talk about cloud computing, somewhere we are talking about big data. The story is roaming behind the big data. So now, because of this, I chosen my topic harnessing big data in the cloud era. Okay. So how? So all of you, I think, aware with the word of harnessing. Any one of you can tell what is the meaning of harnessing? Okay, somebody typed. Okay, nobody typed. So can anyone tell what is the meaning of harness? Okay, nobody will tell this. My God. Can anyone Anyone can tell what do you understand by harnessing so that we should go ahead. Control the resources. Anyone else who can tell? So if you see the title of our presentation is Harnessing Big Data in the Cloud Era. So what could mean of this? Okay, no problem. So I can tell you what is the basically trying to tell through the meaning of this harnessing big data in the cloud era. So basically, something harnessing big data means you are collecting something, you are processing over that, and so there is something you are collecting and do the processing over the huge amount of data. And that data basically collected from not from a single source, that will be collected from the multiple source. So why we added the term cloud era? Because in today's time, you know that we don't carrying computation in your machine. It is over the cloud. So various cloud platforms are available like AWS, Azure, Google Cloud. So they all provide the scalable storage and processing power for handling big data. So the idea of this whole title of this presentation, basically we are using the power of cloud computing to efficiently manage the big data in the today's digital age. So how we can control the things in terms of big data in the era of this large computation over the cloud. So now there is a law which is called this Amdahl's law. So I don't know, are you aware about this Amdahl's law or not? But if you see what this Amdahl law stated, so basically it is the law regarding the actually, you know, the computer architecture. You somehow you gone through the computer architecture, and in computer architecture there are sequential computing uh, processes will be computed one after another. One will be computed, then next will come, then next will come, then next will come. And you have studied it many times that this type of sequential computing is not very much useful because it takes a lot of time, but because some of the component in the processes are independent, so they can run parallelly also. So basically, Amdahl's law is a basically a principle in the computer architecture and the parallel computing that try to explain the theoretical maximum speed up of a program. Okay, when some of the part can be parallelized, because if you know that all the program cannot be parallelized, some of the portion can be parallelized. So that law states about the theoretical maximum speed up. So how this Amdahl's law is defined. So basically, in Amdahl's law, first of all, we take the parameter capital S, which is the speed up S of a program using multiple processor. So definitely parallel computing, you are applying parallel computing, so there will be multiple processors. And the basic formula is given as T1 here, the execution time of the sequential computation, and T and the execution time with the n parallel computation are executed. One means one program at a time, n means n program at a time. Okay. So if you go through with this equation, then speed up effectiveness of parallelization can be given by the ratio of execution time in sequential, execution time in parallel. So Amdahl's law, if A is the fraction of running time a sequential program spends on non-parallel segment of the computation, then S is equal to 1 by A. So obviously you can see the formula, it will be 1 by A. So this is a theoretical upper bound on the best speed up we can get the parallelism in a certain program. So basically this Amdahl's law will gives us a theoretical upper bound on the best speed up which we can get from the parallelism a certain program. So that is 1 by A. A is the fraction of running time a sequential program spends on the parallelizable. So if A will be higher, A will be lower, then this parameter of speed up will become higher. So that is Amdahl's law. And if you want to get details of this Amdahl's law, then you can write Sn is equal to, this Sn can be further written in terms of is equal to 1 divided by 1 minus p. So 1 minus p basically the fraction of the program that can be parallelized. Okay. P is the sequential, then p is 1 minus p. Sorry, p is the fraction of program which can be parallelized. So what is the fraction of program which cannot be parallelized? It will be 1 minus p. And we know that p by n will represent the fraction of the program that can be parallelized divided by the number of processors. So that can also be give your number Sn, and it will the speed up parameter. So if you will come back to basics about the distributions, so just wait, I have to check. Okay, so if you will come to the basics, then you can easily see that it is a collection of autonomous computers connected through a network and distributed software called middleware. So see, if you have using autonomous computer means individual computers, so that it through network, and some distributed software definitely required over that if you are applying or taking the advantage of a distributed system. And that enables computer to coordinate their activities and to share system resources for a common goal. So and what is the characteristic of the distributed system? So the characteristic of a distributed system basically defined by, first characteristic is the user perceive the system as a single integrated computing facility. The components are autonomous, and scheduling and other resource management and security policies are implemented by each system because you are sharing. So security will become the important parameter, and there are multiple points of control and multiple points of failure. The resources may be accessible at all the times, can be scaled by adding additional resources. So definitely this system is scalable, can be designed to maintain availability even at low levels of hardware, software, and network reliability. So now we will go through the definition of what is big data. So as we are talking about big data in the cloud era, so first we should somehow understand that the meaning of big data. So if you take the Wikipedia definition, then big data is the term for a collection of data sets so large or complex that is becomes difficult to process using on-hand database management tools or traditional data processing applications. So see how we will define the big data. Some people can ask that when data will become big. See, your data, see, you always have data and you are applying various algorithms, various data structure over your data. Now, why we need to study the new topic of big data and talk about various things like data mining, machine learning over that? So actually, when the size of data will become large beyond a threshold. So listen carefully. If it will become large beyond a threshold, so that you cannot apply your existing computer science, like whatever database management tools you have, whatever data processing applications, whatever data structures you have, that you cannot apply over that because of the size crossed beyond the threshold. Because if you will see, lot of the data structure having some complexity, and that complexity is the order of n square, n cube, n square log n, like this. So now you can imagine that if billions and millions, trillions number of data will be there, then how complex this algorithm will be. So because of this, when data size cross the threshold, so that your on-hand database tools, traditional available data processing applications, available data structure will not be available to apply over that, that size is called big data. So what are the challenges include when data will become big? So it is difficult to capture curation of data, storage of data, search over the data, sharing the data, transfer the data, analyze the data, and visualization. So all these 8 components will become challenge for us if data will become big. So now you need some theory, some algorithms, some methods so that you can perform all this thing over the big data. So because of this, we study about data mining, machine learning, and everything. Okay, how you mine the large data. So you data mining will answer you. So the trend to large data set is due to additional information which is derivable from analysis of a single large set of related data. So as compared to separate smaller set with the sum total amount of data, uh, allowing correlation to be found too. Now the word is coming correlation. See, if we have very large data, then we apply various algorithm. So mainly we need to identify some correlation among the data. Correlation means how which type of data, what data is correlated to each other. Okay, so that I am giving you example. You know the you all of you heard the recommendation system. So Netflix and Spotify, these companies have their own recommendation system. By there, they recommend song and items to you accordingly. So now you know that there are two type of recommendations majorly, that I will check the pattern and behavior of your purchasing, of your listening music, and accordingly I will suggest you. So that is called content based filtering. So whatever content watched by you, accordingly it will be recommended to you. But another side, if you will go, then there is another type of filtering recommendation which is called collaborative filtering. So collaborative filtering, what they do, first they identify the people similar to you, and they will check what they watch, and they will whatever they will watch, it will also recommend it to you. So not only over the basis of your content, but by seeing the people who are similar to you, that contents can also be recommended to you. So so in most of the time we are trying to find the word similar. So in this large world, how will you define the similar? So similar means something we are looking correlation between multiple points. So we call all the entity in the large data set are points, है ना? So these points are correlated. Uh, I think you aware about the covariance in the probability. So when you will have two random variables, so how two random variables are have uh, correlation to each other, how covariation will be defined. So there is a covariance matrix. So accordingly, things should be considered. So in data science, it is very much important. Whatever you will do, you do after considering the correlation. So, and there is one more example. If you remember that you have a what you call it, this unsupervised data set. So in that case, you don't know what will be the exactly output of a particular data is there. So what you will do, you will try to find the correlated data and make the classify into one cluster type of thing, and accordingly you can classify into multiple clusters as per finding the correlation between them. And whenever new data will join, then you can say that, oh, this new data will have similar to that group, so it will go accordingly. So allowing correlation to be found, spot business trends, determine quality of research. So you can spot business trends. So it is very good. Business service provider people can identify your pattern and recommend the things according to you. And you know the lot of example for this. Determine quality of research. You can improve the quality of research. See, once you have large data set, I think if you are from PhD, then you have data set, then you are always going into the improvement of your research once you have data. You have heard that a lot of people are asking, I'm not getting data, I'm getting data. If I will get data, then I will do this. So data is basically is very good to determine quality of research, because many times theoretical foundations are there which can be validated from the real data. Link legal citations. So if you know the term citation, you cite another's paper, another people will cite other paper. So there is a whole citation network among the people who are doing the researches. So you can create a link of legal citation also. Combat crime, determine real-time roadway traffic conditions. So many things you can do. Actually, I was giving one example. I forgot yesterday or day before yesterday. I think, yeah, Engineers Day was yesterday, na? So I'm giving some one example to the students, that how to find the real world problems. The major problem is that everybody saying that, "Ki, please tell me the way, or please tell me something so that I can find the real world problem." How how the people can find the real world problem? Can anyone say one or two line over that? What will be the magic so that you will get a problem which is realistic, and definitely if solution will be there, then it will be appreciated. I have to check anyone. Yes, sir. Yes, sir. Okay, it is old. See, you can unmute and you can tell. See, it will be very interactive if you people will speak here. Can anyone identify the success mantra for finding the real world problem?
Sir, actually, the participants can't unmute themselves. They can put up in chat box. We will convey the message.
So if they can unmute, then I think there is no problem because less number of people are there. Easily we can catch. Okay, if you don't want to write, then no problem. So I am telling you. So the first keyword to get the real world problem is, I think nobody has wrote. Okay, no problem. No problem. Okay. The first keyword is observe your surrounding. See, you will use all the cloud or this thing or computing power or whatever. So once you have a problem, so you can easily find the problem once you observe your surrounding. You look what is going, what are the challenges in daily life faced by the people. You talk to various community, talk to drivers, talk to rickshaw pullers, talk to bus drivers, talk to the cleaners, talk to your society people. So once you will be more interactive and observable the world, then definitely you will slowly get the insight of the problem. Problems are near you. Just see the traffic congestion, just see the water wastage, and not only after seeing after your observation, just talk to the concerned people also. So they will tell you the real insight. So please make a complete write-up and try to solve step by step. So that the good thing is in this case is you are solving a real world problem which is demanded in the society, because as an engineer your role to serve for the society. So what is demanded by the society and you are solving that problem, and definitely once you will be able to solve that problem, then that will be efficiently used by the people. So that is the idea. So I talk this thing because it is written now. If you will have data, then you can determine quality of research. And at last line, real-time roadway traffic conditions. So in this case, real-time roadway traffic conditions. So this is also a one real problem which you look around you and you can improve this. So now once we talk about the big data, so I hope you are aware with that or not. So at least we should go through that. Big data by the three V's. So what is this three V's basically? So first of all, here you should see big data means transactions plus interactions plus observations. So you do the transactions with the data, do the interactions with the data, and observe the data. And if you see here, day by day, increasing data variety and complexity. Data is increasing in terms of variety and in terms of complexity. And here, data is day by day increasing in the size. So what is this 3V? So big data, basically 3Vs means volume, defined by volume. Volume means large amount of data. Velocity needs to analyze quickly because data is generated. See, it is a streaming of data, because if you will see the flow of data, it is keep coming, keep coming, keep coming. Variety means types of structured and unstructured data is available. So if you see here, the big data then big data dealt with three things: speed, velocity, size, volume, and third, variety, complexity. So here you can see how data is increasing. So increasing data from ERP to CRM to web pages to big data. Web data is also big. You know that there are many types of websites are available over there. And if you see over the larger side, you have external demographs, social interaction feeds, speech to text, sentiment, mobile web, user click stream. So in this range, data is become in terms of petabytes. So here you can see it is moving from gigabyte to terabyte to petabytes, and it is increasing the data variety, because if data will become very large, and now you can understand it will have a different type of data, and increasing the complexity also. Okay, so complexity will be increased when we increase the variety. So these are the three V's. So you can see every V one by one. So volume, basically massive amounts of data from multiple sources are coming. So this is related to the volume. So if you see, data volume is increased 44 times from 2009 to 2022, and you can understand the meaning of 44 times. So it is from 0.8 zettabytes to 35 zettabytes. Data volume is increasing now exponentially. Okay, exponentially means very high increase is there if you see the exponential curve. So if you can see that curve, so data is increasing. So that is increasing exponentially. So because of this, it is in terms of tweets per day. But in this case, data storage, if data size will increase, then data storage will also be required more. So if you will see, data storage growth is also increases by huge. So, and I think you know the petabyte. 1 petabyte is 1024 terabytes. So because of this volume term, exponential increase in the data and required storage also. So you can see the example of big data. So Google is generating petabytes of data every day. Twitter or X is generating 500 plus terabytes of tweet data. Facebook generating 250 plus petabyte of log data every day. So this data volume is increased because nowadays lot of data is in the form of video. So because of this video data, the size is increasing day by day with very high speed. So now you can see that we have now 100 billion of RFID tags today, 6 billion camera phones worldwide, 100 millions of GPS enabled devices sold annually, 2 plus billion people on the web, 15.14 billion smart IoT devices now deployed. So now you can understand these all are the sources for collecting the data, major sources for collecting the data, and you can see its number. So now you can get the idea how much data they are collecting. So if you see this machine, so this is a basically large hadron collider. So why this machine is mentioned here? Because it generates 15 petabytes per year. It generates 15 petabytes of data per year. So what is this machine basically? So this machine basically world largest and most powerful particle accelerator machine. So that is basically located at European Organization for Nuclear Research at Geneva, Switzerland. So it is also generating 15 petabyte data per year. And if it is generating that much of data, then you have to store the data because need to do analyze the data. So the EarthScope is the world's largest science project designed to track North America's geological evolution. This observatory records data over 3.8 million square miles, amassing 67 terabytes of data. So it analyzes seismic slips in the San Andreas Fault, sure, but also the plume of magma underneath Yellowstone and much, much more. So this is also the example how much data you are collecting. So now easily you can understand the importance of cloud computing, virtualization because of the computation of such big data. Now the second point is variety. So what we mean by variety? Variety basically you have various types of data. See, if your sources of data are very high, then the variety of data will also be high. So just take one example in the federated learning, we deploy we deploy the machine learning model over the various edge devices, and that will be trained over that. So edge devices means local client side devices, and client data will be used there only because of security and run model individually. Now you can understand that now how model will be trained by the data, because every user's data are different. They are not uniform in nature. Okay. So heterogeneity will be there. So if you are collecting data from the various sources, then variety will always be there. So variety can be different types. So it could be structured. So if it will be structured, then you can collect it into the spreadsheet and some database. It could be semi-structured JSON files like JSON files. And it could be unstructured data like videos, images, and social media post, text feed. So all the unstructured data, because for that analysis, you need to do some hard work. So variety of data leads to the complexity in the data. So relational data means structured data, text data, it is unstructured data, semi-structured data, graph data, streaming data. A single application can be collecting many types of data. Big public data like online data, weathercast data, weather data collecting from the various sensors, finance data. So this variety of data will able to increase the complexity in the study of big data. So here last line you can see, to extract knowledge, all these type of data need to be linked. So this is also a big task to do. So a single view of the customer you can see here. So this is a customer which is connected with many things, some gaming devices. It is the structure of social media, website. How person is connected through the World Wide Web. Banking, finance, own history, our known history, different purchase website, different entertain website, different gaming website, different social media website. So now most of the persons are connected with these sites. So these websites are also collecting data day by day. And third V is called V for velocity. So data is being generated fast and need to be processed fast. So obviously, if data is streamed, it is generated according to the time. More and more data is coming according to the time. So definitely we need some of the algorithms which can process it fast. So I'm giving you one example here. You know that Google earn most of the profit from the Google advertisement. So how Google advertisement will be done? Because see, you will type something over the Google search bar. So that is considered as a keyword. So according to the keyword, many sites are searched. And you see, according to your keyword, some of the advertisement will be displayed for you. Okay. Now just think over the Google server side. How many keywords are appearing from the Google server? See, there are many people who those are using Google for searching. So many keywords are appearing over the Google server. And what is the task of Google server? See the keyword, search the pages accordingly. Not only search the pages accordingly, but Google should share the relevant ads also, है ना? So in the case of in this example, all the keywords those are appearing from the user side. These will be considered as the streaming of data. So keywords are keep coming, and what algorithm will be processed? For every keyword, one algorithm should be executed so that Google can select the best three or four advertisement for that user and can be displayed. And see how this process will be done. So once Google see the keyword, so some market representatives from all over the field are there with are there, and once Google will see the keyword, accordingly they will raise that I am interested in this keyword and wanted to give advertisement. Then Google do online auction at that time. So who will be the top bidder in that auction? That people's ad will be published. So now you can see this algorithm for selecting best three persons on the basis of keyword cannot be static. It should be runtime because keywords are keep changing. So in this case, this word you can easily understand. Data is being generated fast and need to be processed fast. So that timely advertisement can be shown, and again next keyword will come, then they will do the same exercise. So here I wanted to clear you not only the uh, basis of auction and highest bidder will be given to the advertisement, but Google also check the click ratio of their advertisement. Okay, or so how many times clicks were there over his or her ad in the past? That will also one of the criteria, because Google earns the money by every click. So if clicks will be high over that advertisement, then Google will earn money. Okay, so online data analytics. So now you can understand all the things. So on the spot, online, all data analytics should be done at that time. There may be many examples. You are watching live matches, and if I wanted to give ad accordingly, then I have to process the data at that runtime. Late decisions, if you will take late decisions, then missing opportunities. Definitely, you can easily understand by this example, late decisions are not allowed here. So see, if you are not able to run algorithm and result will be displayed of the search without advertisement, then Google will lose. So what are the example? E-promotions. So based on your current location, your purchase history, what you like, send promotions right now for your store next to you. So everything, this is the example. Healthcare monitoring, sensors monitoring your activities. So once data is coming from the sensors, this is also the streaming of data. So suppose you put some camera over the watching the growth of the plants in the field. So that camera is giving feeding continuously, and you have to apply some online algorithm to process over that. And every time algorithm execution should be changed. So what is the real time or fast data? Social media and networks is one real time and fast data. because all of us are generating data over the real over this social media like YouTube, Flickr, Twitter. You can see that many people are uploading how you can see how many number of videos. Once some people will upload the video, then other people will come by giving the data in terms of text by typing some comment or anything over that. Okay, so mobile devices are also responsible for collecting the data, and sensor technology and networks. So you can see that there are a lot of sensors are deployed here and there, and they are also collecting the data. The progress and innovation is no longer hindered by the ability to collect data, but by the ability to manage, analyze, summarize, visualize, and discover knowledge from the collected data in the entirely manner. So, how real-time analytics decision requirement should be done? So, for all this real-time analytics and everything, we need the resource as a cloud. So, product recommendations that are relevant and compelling, learning why customers switch to competitors and their offers in time to counter. So, see, there are some examples of various analytics, and on the basis of analytics over the customer's data, that service provider should make some decision. Friend invitations to join a game or activity that expands business, preventing fraud as it is occurring and preventing more proactivity, improving the market effectiveness of a promotion while it is still in play. And I'm giving you some example, credit card, banks who provide the credit card also do the analytics over your spend pattern, है ना, spending pattern. So sometimes you spend something unexpectedly, which you never did in past, then definitely they will get some alert and they will warn you that your account has been debited this. Have you done it or not? Do you want to allow or not? So many type of analytics are going on, some for security, some for business promotion, some for understanding the customer behavior so that people can take that decision. So now it was also said that not only three V's, one more V is there. So veracity, so the quality, accuracy, and trustworthiness of the data. So data should be not in doubt. So uncertainty due to data inconsistency, incompleteness, ambiguities, latency, deception, model approximation. So veracity, the quality to is required to fix the quality of data, accuracy, and its trustworthiness. So here you can see all the four V's: data at rest, volume, data in motion, velocity, data in many forms, variety or complexity. Veracity is data in doubt. So now the model has changed. The model of generating, consuming data has changed. So how this model has been changed? So first we need to look what was the old model. So few companies are generating data, all others are consuming the data. So some people are only capable, like newspapers were there. So you get the news once you will get the newspaper at your door. Now you can have your own channel and you can generate the news from your home. What is the new model? All of us are generating the data and all of us are consuming the data. So that is the important change has been made in the old model. See, initially, until unless you will not get some entertainment over your television, you will not be entertained. Now you can upload any of your entertaining video and people can see your video also. So, see, because of this once we develop anything, so scalability is very much required, because as per evolution of the time, things are changing. So once things are changing, your model should be adaptable to that changes. Okay. So now if we will talk about the harnessing of big data, so now you can see this is online transaction processing, then online analytical processing, and real-time analytics processing. So how they are doing this? So some operational database for OLTP, some data warehouse for OLAP, for RTAP, there will be a stream computing. So in this case, we are reporting and human analysis on historical data test at rest. So the data at rest. Now in the case of online analytical processing, various data warehouses are there. Analysis of current data to improve business transactions. Okay. Now, stream computing. So in this case, real-time analytic processing to improve business response. So what is happening here? Client drivers, data center, so backup solutions. So this all structure, there are various database servers, there are various storage nodes. So this huge structure will be used once we are dealing with the harnessing with big data. So what's driving with big data? So now you see business value is going from low to high, and complexities were also going from low to high. So if you in this curve, if you will see this region is come under business intelligence. So what business intelligence means here? Ad hoc querying and reporting. So you can do any ad hoc query and reporting will be done. Some data mining techniques can be applied for like clustering or anything else. Structured data will be there in this case, and small to mid-sized data sets, it will work. And if you will go in this region where predictive analytics and data mining is there, so definitely become large and complex, because complexity become high and business value also become high. So optimizations, various optimizations and predictive analytics will come into the picture here, and some complex statistical analysis is there. So all type of data and many sources. Okay, so you know that there are multiple sources, those are collecting the data, all are giving data to you with variety of data, and you have very large data set and more of a real-time data set. So this is a driving of big data. So what is the evolution of business intelligence in terms of big data? So in the 90s, BI reporting, this online analytical processing and data warehouse, so business objects. So this is appearing in the 90s era, and in the 2000 era, interactive business intelligence and in-memory RDBMS are there. So that is 2000 era. So here data speed increased from 90 to 2000. Speed of data will be increased. And between 2000 to 2010, scalability, data is too much scaled. So big data, batch processing is used, distributed data center is used. So various technique was there. Hadoop, Spark were very much in use at that time, HBase, Cassandra. And now after 2010, we have big data, real time and single view data. Graph databases are there. See, if you want to understand the data can mainly be categorized into three categories. First category is high dimensional data, which is the data can be plotted in any d-dimensional space. Okay. So high dimensional data, like you are representing some of the points. Okay. Now, second category of data is graph data. Graph data is a data in which different entities are shown and it is connected. So it is in the form of matrices or in the form of edge list of the graph. And third type of data is infinite data or data streaming. So that type of data basically keep coming, keep coming, keep coming. There is no tail of data. Okay, so it is keep coming. So after 2010, big data, real time and single view and graph data will also be to the picture. So graph data will be why we are categorizing data into three category, because the process over to do any predictive analysis over every type of data will be different after seeing the data type. Is it graph data, stream data, or high dimensional data? So what big data technology is required, which is closely with which is in the close to the cloud. So here I will take just 5 minutes break to take some water and then I will join. Is it fine? Hello. Okay, so so till now, do you have any doubt regarding the big data, or if you want to discuss anything which you encountered anytime regarding the big data? Participants, any question or any query which you have in your mind regarding big data and wanted to discuss here? Yes. Okay. So now if you will see the big data technology. So if you remember my previous lecture, so we talked about some distributed file system. So this thing is clear from the starting. Data is large. We need to compute. So only solution is that we have to distribute data over the different chunk or different site, because you cannot load the data on one side to speed up. This we have seen in the first slide. To speed up, you have to take the advantage of parallelism. So how parallelism can be done? So you need two things basically to apply the parallelism. So first thing you required uh, a software service or a tool so that you can distribute your files. Second, you can do the computation after distribution. So if you remember, I told you that facility will be provided by Hadoop, and Hadoop will have Hadoop distributed file system regarding this. You know? So map reduce technique has been used. I discussed that map reduce part also. So once you have fast data, then this Hadoop, Vertica, MapReduce, Esper, KDB, Greencolumn, Netsa, Teradata, that can be used for the fast data. So it is increasing age and maturity. So if you see top to bottom, as per the increasing age and maturity, that will be used. So in this case, data is in terabytes. But once you will come here, so here you can see growth of data is happening. Now they use Hive, SciPy, MATLAB, Revolution R, SPSS, you know, statistical analysis tool, AMPL, SAS. And finally, if you want, so this is for big analytics. And if you wanted to know some deep insight, if you wanted to know deep insight, क्यों वो चेक की कॉपी थैंक यू सुनो स्कैन करके ही भेज देना. So if you wanted to look deep inside, so I wanted to tell you how you can play with the big data, analyze, visualize, so go and dig it and see the deep inside of that. So unsupervised learning, social media analytics, sentiment analysis, predictive modeling, network analysis, visualization, simulation. Network analysis word is written if data is graph data. Okay. So there are various business objectives which we want to achieve here. Mass customization of services, response to market trends, identifying real-time cost optimizations, faster, more accurate decision making, better and more holistic R&D, automatic supply chain management. So these are the business objectives. So this is whole big data technology which we can understand. If big data moving by parts like fast data, big data analytics, deep insight, and how technology is changing when data size is increasing from terabyte to petabyte to exabyte to zettabyte. So now if you see big data analytics, big data is more real time in nature than traditional DW application. DW, if you know, it is data warehouse application. Some traditional data mining and data warehousing application. So big data is more real time in nature. So traditional data warehouse architectures like Oracle, IBM are not well suited for big data apps. I told you initially, big data means your existing database tools are not going to implement over that. Even if you want to just sort or search or write any SQL query, then you can imagine the complexity for this large data set, how it will search from this terabyte or petabyte data set. So there are some architectures can be used, shared nothing architecture, massively parallel processing architecture. So there are certain architectures which can be used here. Okay. So if you will see this flow diagram, so here cumulative cash flow, accelerating time to value. So big data analytics is leading in that in comparison to data warehouse appliances. Okay. So, but time will also be taken less in the comparison of this. So big data landscape, you can see there are various apps, various infrastructure developed because of this. So vertical apps are there, ad media apps are there, business intelligent apps are there, analytics and visualization applications are there. So vertical apps examples are given, ad apps example are given, business intelligence given, IBM, Good Data, Cognos, analytic and visualization, Data, Ultras, SAS. I think somebody has messaged. Okay. Clear, sir. Host. Oh my God. Okay. So various infrastructure is developed, analytics infrastructure, cloud era, this cloud era, DataStrex, and Mapr, Parcel, Vertica, operational infrastructure, 10gen, VoltDB, infrastructure as a service, Mortar, Cubal, structured database, Sybase, MySQL, Oracle. So these infrastructure and apps are available to handle the big data landscape. Okay. So main big data technologies are used Hadoop, NoSQL database, analytical RDBMS. So I'm not going into the detail because Hadoop I have covered. So currently enterprise big data processing system for business intelligence, all three together. So we have just seen this picture before some slides. So I'm not going to discuss again. So if you remember, if data size is increasing, then in this way you are using this application. So now what is the shared nothing architecture and massively parallel processing system? So shared nothing, you know that there are some parallel architecture. You shared main memory in some parallel architecture. System will have individual main memory, but they will share the disk storage. But in the shared nothing architecture, we are not going to share anything. All components are independent. So reliability will matter in this case. No? If one site will fail, you can recover from the another site. Massively parallel processing is there. So scale out architecture is well suited big data applications. So what is massively parallel processing architecture available? So Amazon Elastic Cloud Computing. So EC2, if you remember, I talked about EC2 in my last lecture. EC2 clusters are there. Cluster is a collection of a lot of nodes, high-end nodes together through the switches. Azure parallel data warehouse is there. So if you will see enterprise big data processing system. So here first is data layer, then server layer, then client layer. So data layer is stored in terms of RDBMS, Hadoop NoSQL, high performance analytic database. Some flat files are there, which is interacting with the server layer. At server layer, you will see enterprise console server and data models. Various data models are used in this case. And in the client server, thin clients are there. Analyzer are there, dashboard designer are there, enterprise console is there. If we talk about thick client, then schema workbench, aggregation designer, metadata editor, report designer, data integration, data studio, these are available. So if you see the sources, there are different files, databases, ERP system existing. MySQL CSV files will be there. So this is the physical layer structure, and this structure we have seen in detail. So this is the enterprise big data processing system. Another new platform for big data analytics is in-memory based system. So what is this in-memory based system? So just you can see the example of Spark here. So here in this architecture, if you will see, streaming of data sources is coming from this side, some source of streaming data, and there is some source of static data. So now you can see that go to the Spark streaming, and in the Spark streaming, they will come out in the form of process data. And if you see, Spark streaming is connected with Spark MLib, GraphX, Spark data frames, and Spark SQL. So here, Spark MLlib basically use trained models on live stream of data, train models with the live stream. And if you see Spark GraphX, so it traverse graph on live stream if you have graph data, okay? And Spark SQL query on live stream with SQL, and Spark data frames and dataset give the facility to apply functional transformation on live stream like MapReduce. So that process data will be in the form of HBase, MySQL, MongoDB, or whatever. So, if actually I need to talk about something, the integration of cloud computing and big data. So in last class, I talked about this IT resources provided as a service. So you can compute, storage, database, queues, cloud leverage, economies of scale, and commodity hardware. So we talked about the economies of scale by the clouds. So it will give pay as you go concept, cheap storage, high bandwidth networks, and multi-core processors. So you have multiple geographically distributed data centers like those they are offering cloud services like Microsoft, Amazon, Google, we know that. So these all are cloud computing. So cloud as a application, cloud as a platform, cloud as an infrastructure. So you can see multiple people are connected through this cloud computing region. So we talked about benefits also, cost and management will be improved, deployment time will be reduced, scalable, reliable, sustainable. Type of cloud computing. So we talked about it is public cloud, private cloud, hybrid cloud, commodity cloud. So I'm repeating again. Public cloud is a computing infrastructure is hosted in the vendor premises, but for particular dedicated organization, if they are very much aware about security. Yes, for security, they need to go for public cloud. Sorry. Not for security. See, for security, there is a private cloud. Computing infrastructure, basically public cloud, you are accessing public cloud, so data will be shared with multiple sites. So private cloud computing architecture is basically dedicated. That is basically related to the security, है ना? So uh, please wait. Okay, so private cloud computing architecture is dedicated to the customer and it is not shared with organization. So here we talk about when we go for security, है ना? So hybrid cloud organization hosts some critical secure applications in private clouds. The not so critical applications are hosted in public cloud. So this is the hybrid nature. So you can see this commodity of cloud. This is the cloud, this is public, this is private. So you can see this structure. So classification of cloud computing based on service provided. So we also talked about that infrastructure as a service, platform as a service. So Amazon EC2, Amazon EC3 is the example of IaaS, infrastructure as a service. Platform as a service, Microsoft Azure, Google's application engine is the example. Software as a service, Gmail, Hotmail, Google Docs are example, which provides the software without installing at the user site. So this is the example of infrastructure as a service. The end user having this, all the IaaS vendor is providing this. This is the virtual machine. By this, they can access. And if you will go architecture of cloud-based IoT application, so this is the various end devices. This is IoT application server. And here big data base server and deep learning server on cloud computing. So in this way, things are happening through the IoT application servers. So more refined categorizations can be seen by this diagram. So you can see that storage as a service, database as a service, information as a service, process as a service, application as a service, platform as a service, integration as a service, security as a service, management, governance as a service, testing as a service, infrastructure as a service, machine learning as a service. So this is more refined categorization for understanding all the services of cloud computing. So here you can see security as a service in this layer is a platform as a service. So if we talk about security as a service, then this fourth layer, storage, database, information, processes as a service, application as a service will appear. If we talk about integration as a service, then database, information, process, and application will appear. And if we will talk about platform as a service, then process, information, database, storage, and infrastructure will appear. So by this way, the pattern of categories of cloud computing provider allow you to see a discrete set of services within your architecture. Now, key ingredients in cloud computing by which it is developed. So I don't know, you are aware that everything is possible because of internet. Okay. And we need to do the virtualization. So uh, virtualization can be done in the cloud computing. And it can be done by P2P network. So peer-to-peer network structure is very much important. So if you are really interested to do something in the cloud computing, so please understand the peer-to-peer network structure. Because what is the meaning of virtualization? Basically, you need to focus over this also. Basically, virtualization is nothing. It is a technology that creates a virtual version of computing resources, not the actual version, virtual version of computing resources, like storage or networks. So once you use the cloud computing, it will allow multiple users and application to share the same physical infrastructure. So basically how it works. So basically how basically this cloud computing can be done. So you know the example of Microsoft Azure or all our virtualization. So basically on the server side, there will be a physical hardware. Okay. So physical hardware basically exists: CPU, memory, storage, network components, everyone is there. After that, there will be a hypervisor layer that is basically called virtual machine monitor, and VMM. All of you heard that. So over that hardware, we will install a VMM, which is called a hypervisor. So basically, this is the main software which enable to divide the manage of this hardware among the various clients. So now you need to create a virtual machine. So once hypervisor is there, then it portions virtual machine can be run in your own operating system like Windows, Linux, है ना? So it behaves like a real computer, and each virtual machine will be isolated, and there will be management layer which is called basically cloud provider. So in this way, actually virtualization works. I hope that in some lecture you have gone through the detail. So virtualization is the key part. So what are the, see, all are the key ingredients key ingredients in the cloud computing. So service oriented architecture, utility computing, which is on demand, virtualization, which is peer-to-peer network, SaaS, software as a service, platform as a service, infrastructure as a service, and the web services in cloud. So everything as a service basically. So what is utility computing? It is infrastructure as a service. So why buy machines when you can rent cycles? Example, Amazon's EC2 rack space, platform as a service, give me nice API and take care of the maintenance. Software as a service, just run it over for me, Gmail, Salesforce, like this. So now show you how parallel distributed file system will run. So HDFS will be used. Just you can see, you may have different data node. Node actually will do the computation for you. Nodes are the server, basically, individual server. So in this example, just see how distributed file system will work. So 6 nodes are there, 6 parallel servers are there. So what you have done, you have a program, big data, sorry, you have a big data of, call it B. And this big data is divided into equal sizes chunks. So that chunks are B1, B2, B3, B4, B5, B6, like this. And that chunks basically distributed over the data node or servers. So you can see that chunks are distributed over the data node or server. And to maintain the reliability, up to 3 replica of every chunk should be there, up to 3. So up to 3 will take care reliability. So it could be 2 or 3. So you will see B10 is here, B10 is here, B10 is here. So 3. So if one server will be crashed, it can be recovered from another. So you can observe that there is no more than 3 replica of the chunk to maintain the reliability. So this is the structure, a large data B divided into the chunks, and it is distributed over here. And if you see the name node, name node actually contains the metadata, file name, replication, block IDs, and everything. So here you can see how the chunks are distributed over the server node. That information is maintained here so that you can collect the data in case of site failure accordingly. You know? So this is a parallel distributed file system which we use. So this is also the example of MapReduce system, and I already discussed in the last class. So I will not go into the detail. So all this structure we discussed in the last class. Okay, how parallelism be given. So the impact of cloud computing on data analytics and big data. So if you see cloud computing, a transformative technology landscape of data analytics and big data, it refers to the delivery of computing services such as storage, processing, and networking over the internet. Instead of relying on local infrastructure, organization can leverage remote data centers to access powerful computing resources. So significance of data analytics and big data here. So you can see some of the point. Data analytics and big data play a vital role in today's digital age. So these disciplines basically empower organization to extract invaluable insights from vast and complex data set. By analyzing patterns and trends, they enable data-driven decision making, enhancing efficiency and competitiveness. And in business, basically data analytics uh, adds in optimizing operations, identifying customers' preferences, and forecasting market trends. In healthcare, it supports research and patient care. In essence, data analytics and big data are the driving forces behind innovation and informed choices in our data-rich world. So, how cloud computing and data analytics are related? Cloud computing refers to the delivery of computing services, including storage, processing, and networking over the internet. It allows user to access and use resources hosted in remote data center, eliminating the need for on-site infrastructure. We know that cloud computing plays a pivotal role in data analytics by providing the infrastructure needed to the process. It enables basically organization to access uh, analyze the data for various sources, facilitating more extensive and complex data-driven insight. Cloud computing, basically. So, what is the benefits of cloud-based data analytics? Leveraging the cloud for data analytics offers several advantages, like it allows for elastic scalability, meaning resources can be easily adjusted to match the demands specific analytics task. Moreover, cloud-based analytics can be cost-effective as organizations pay only for the resources they use, reducing the need for extensive upfront investment in hardware. Additionally, cloud services often come with advanced tools and services that can enhance the efficiency and capabilities of data analytics. So, what is big data in the cloud? Big data refers to extremely large and complex data sets and that traditional data processing methods struggle to handle. See, always they will write this definition. Big data means when traditional data processing methods struggle to handle something big or complex when your existing methods are failed to handle those. So that threshold is called. It is characterized by the three V's: volume, velocity, variety. This data often includes structured, semi-structured. Cloud computing provides an ideal platform for handling big data due to its flexibility and scalability. And it offers on-demand access to vast computational resources, making it possible to process and analyze massive data sets efficiently. Cloud-based big data solutions use distributed computing framework. So we have seen like Hadoop and Spark to process data in parallel, ensuring faster results. See, some of the deficiencies we uh, what you call we have seen that how we will get the distributed computing. So I told you Hadoop distributed file system can be used and also for MapReduce process. But still Hadoop will lack in something. So first, there are some problem in Hadoop. So iterative, uh, it is if inefficient for small data, and iterative tasks are there, and it requires high resource compute consumption. And second, latency is little bit high. So to overcome with this deficiencies, we will go to the Spark. Okay, so Spark is also designed for distributed computing system for parallel processing. So scalability is a key advantage of cloud computing for big data. Cloud providers offer elastic storage solutions that allow organizations to scale their data storage up or down as needed. So this scalability is cost effective as business only pay for the resources they use. So impact of cloud computing on data analytics. So how cloud computing impacted the data analytics part? The impact of cloud computing on data analytics has been profound. With the cloud's powerful computational capabilities, data analytics processes have become significantly more efficient and accessible. Cloud-based solutions allow organizations to process and analyze vast amount of data in real time, enabling decision making. Further, the cost effectiveness and scalability of cloud services have democratized data analytics, making it accessible to business of all sizes. So finally, the integration of cloud computing in data analytics has revolutionized the way organizations leverage data to gain insights and make informed decisions. So you can understand, if you have the large data, you can also do the big data analytics at your hand without establishing the large infrastructure. So what are the various challenges and concerns we have? So implementing data analytic and big data solution on the cloud bring about several changes like security and data privacy. Definitely, if you are sharing something over the internet for processing, so security and data privacy will become the major issue. Storing sensitive information off-site raises concerns about authorized access and data breaches. So you know that in class we talked about there are different regularities for handling this. Secondly, if you are doing something over internet, you are using communication medium, so you have to compromise with the latency. So because of this, people are doing research over the 4G, 5G, 6G to improve this latency so that you can do very realistic application through that like robotic surgery. So latency and network issues can arise due to the physical distance between the cloud server and end users. Now, this may lead to delays in data transmission and processing, impacting real-time analytics applications. So, optimizing network infrastructures and selecting geographical appropriate cloud regions can help mitigate this challenge. So, if you see in last lecture, I talked about always client should be approached with the nearest server. So another concern in vendor lock-in where a company becomes heavily reliant on a specific cloud service provider system. So this can limit the flexibility and pose challenges if the organization wants to switch provider in the future. So switching to cloud is also a challenge. Employing open standard and utilizing multi-cloud strategies can help alleviate this risk, allowing for greater adaptability and scalability in the long run. So what are the future trends? So emerging technologies and new tools and technologies such as edge computing, quantum computing, AI ML advancement are likely to reshape how data analytics and big data are managed in the cloud. So potential advancement in cloud computing, cloud providers are expected to enhance their services focusing on security, performance and compliance. And definitely improvements always required. Additionally, serverless computing and hybrid cloud solutions will likely become more prevalent. Evolving data analytics in the cloud, the future will likely witness the integration of real-time analytics because a lot of IoT data is there. Multi-cloud strategies will be useful. So as data volumes continues to grow, that emphasis will shift towards improved data governance, data quality ethics. So moreover, automation of data processing and analysis will become increasingly important. So at last, keeping up with these trends is essential for organization to harness the full potential of cloud-based data analytics and big data in the coming years. Okay, so this is the end of my presentation. So if you have any query or question, then you please ask or type. I will see from there.
Participants, if you have any query, you can put it up in the chat box. So it seems there
Okay,
are
so not,
no,
fine. Okay.
it seems there are no more queries. Thank you, sir. You can conclude. Thank you for such wonderful session on big data and cloud era.
Okay. Thank you. So I'm signing out from here. Okay.
Yes, sir. Sir, one question is there.